In 1966, a handful of engineers promised they could build the tallest skyscrapers on Earth while using half the steel the Empire State Building needed, an idea so radical most experts called it reckless, even dangerous. Yet with the force of politics and Rockefeller money behind them, the Twin Towers weren't just approved. They became the world's largest untested structural experiment, right in the heart of New York City. This is the untold story behind how the Twin Towers were really built. A race where ambition eclipsed caution, 30,000 people lost their livelihoods, and thin steel walls held up ambitions as vast as America itself. If these towers rewrote every rule of skyscraper engineering, why did the world never follow their blueprint again? The real answer starts here. The numbers didn't add up. The Empire State Building, that steel titan of the 1930s, needed 60,000 tons of iron and muscle to reach 102 floors. Now, on paper, the World Trade Center towers were supposed to rise higher, 110 floors each, using just 42,000 tons per tower. That's a third less steel for a bigger, heavier building. The claim sounded like a misprint. Engineers across the country shook their heads. You can't cheat gravity with optimism. You can't build higher with less and expect the wind, the weight, and the unknown to play along. In 1966, the proposal landed on the desks of New York's engineering elite. They read the numbers, checked the ratios, and reached for their red pens. The old formulas dictated thick columns, a dense skeleton, weight everywhere. But the new plan called for something else. Thin steel walls, barely an inch thick, would do the heavy lifting. The rest, open space, endless glass, would be suspended between them. Critics called it reckless, even suicidal. Letters to the Port Authority warned of wind-induced sway, steel fatigue, and a skyscraper that might hum, shudder, or worse. One consulting engineer wrote, "No precedent exists for such a structure. The margin for error is razor thin." Yet the project wasn't stopped. The promise of half the steel and half the cost overruled the chorus of doubt. The towers would rise not because everyone agreed they should, but because the people in power decided they would. Every calculation, every warning, every sleepless night, none of it slowed the momentum. The world was about to watch an untested idea become the tallest thing on Earth. Minoru Yamasaki's blueprint looked like science fiction. Instead of a forest of columns, he drew two hollow rectangles, each ringed by 236 slender steel columns spaced just over 3 feet apart. These columns weren't just decoration. Welded together with deep steel spandrels, they formed a rigid shell. The building's bones, not its skin. The idea was simple and radical. Move all the strength to the outside. Let the walls, just an inch thick, carry the weight and fight the wind. The interior core would house elevators and stairs, but the floors themselves would float, open, uninterrupted, 40,000 square feet at a time. For tenants, it meant endless space and sweeping views. For engineers, it meant betting everything on a theory no one had tried at this scale. Leslie Robertson, the lead structural engineer, ran the numbers again and again. Wind tunnel tests in Canada, computer models, full-scale prototypes, every tool they had they used. Still, the old guard scoffed. No skyscraper had ever trusted so much to so little steel. But the Port Authority, under Austin Tobin, was looking for a reason to say yes, not no. David Rockefeller, the city's most powerful banker, wanted a monument to American ambition. When New Jersey's politicians balked, the Port Authority offered a deal. Take over the struggling PATH train, swallow its losses, and win the votes needed to build. The subsidy was buried in the paperwork, but it worked. With the political machinery in motion, the World Trade Center was greenlit. The tube-in-tube experiment would become reality, no matter the risk. Radio Row was gone by noon. 300 businesses, some with neon signs older than the Port Authority itself, were swept aside for progress. Oscar Nadel, who sold vacuum tubes and transistor radios on Cortlandt Street, led the resistance. He filed lawsuits, rallied shopkeepers, and staged parades for the press. But the bulldozers didn't pause. By the end of 1966, a neighborhood that once pulsed with the hum of commerce was stripped to bare dirt. 30,000 workers scattered, their livelihoods erased by eminent domain. The empty block became a pit, 70 feet deep, right beside the Hudson River. That's where the next gamble began, the bathtub. Engineers needed a way to keep the river out while digging down for the tower's foundations. The solution was borrowed from Milan, a slurry wall built panel by panel, each trench filled with bentonite clay to stop the sides from caving in. Only after the steel cages were lowered did workers pour concrete from the bottom up, forcing the slurry out and sealing the wall. In January 1968, disaster nearly struck. A breach opened in the unfinished slurry wall. Hudson River water surged in. If the wall failed, the river would flood not just the site, but the subway, the streets, everything below canal. For 48 hours, crews worked non-stop, pumping concrete, driving steel, racing the tide. They held the line. The site was saved. The cost, millions over budget, months lost, was measured in dollars. The cost to the city, if they'd failed, would have been unthinkable. Steel arrived not as raw beams, but as precision-made modules, each one a slice of the tower, 14 inches wide and just an inch thick. Welders and ironworkers set these panels side by side, every 3 feet, climbing higher with each new row. The columns locked together, spandrels welded tight, forming a continuous shell that could flex with the wind instead of fighting it. At the top, gusts could push the tower 12 feet off-center, a slow, rolling sway that engineers called safe, even if it felt like sailing to those inside. Leslie Robertson and his team trusted the math, but the real test came on the steel itself. Every piece had to fit within millimeters. A single misalignment could ripple through the entire frame, threatening the whole experiment. To keep pace, construction crews used cranes that climbed the building as it grew, inventing new methods to lift steel and concrete faster than any city had seen. The rhythm was relentless: bolt, weld, check, repeat. But height created a new challenge: how to move 50,000 people up and down 110 floors without filling half the building with elevator shafts. The answer was the Sky Lobby. Instead of one endless ride, express elevators shot to transfer floors, giant lobbies in the sky where passengers switched to local cars. 2 sky lobbies per tower, one on the 44th floor, another on the 78th, turned vertical travel into a subway system, freeing up valuable space for offices and giving the towers their signature open interiors. The result was a vertical city, engineered to rise, bend, and breathe with the wind. The towers opened to fanfare, but the crowds never came. For years, entire floors sat empty, sunlight bouncing off bare concrete where tenants were supposed to be. By the end of 1974, less than half the space had been leased. Some reports put occupancy at just 37%. The private sector stayed away, put off by high rents, elevator confusion, and the sheer scale of the gamble. The Port Authority, once landlord to a city's ambition, found itself managing a white elephant. To fill the gap, government agencies stepped in. The General Services Administration and New York State signed massive leases, taking over 1 million square feet by 1976. Only then did occupancy finally creep above 50%. For all the talk of progress, the world's boldest towers needed a bailout just to stay half full. The world took notice. In 1973, the Sears Tower in Chicago opened its doors, taller than the Twin Towers, but built on the same principle. A rigid tube of steel at the edge, open floors within. Fazlur Khan, the engineer behind Sears, credited the New York experiment for proving what was possible. From that point on, the tube-in-tube system became the blueprint for super talls everywhere. Petronas Towers in Kuala Lumpur, Jinmao in Shanghai, Burj Khalifa in Dubai. Each one a direct descendant of the World Trade Center's gamble. But the legacy wasn't just about height. After September 11th, every building code in America changed. Wider stairwells, more fireproofing, extra redundancy. Modern skyscrapers are safer because of what was learned and lost in those towers. The Twin Towers' bones run through every skyline now, a silent lineage of risk, reward, and the lessons written in steel. In 1966, the World Trade Center's designers proposed building the world's tallest towers using just 42,000 tons of steel, nearly a third less than the Empire State Building. This radical approach, powered by the tube-in-tube structure and 236 perimeter columns, faced fierce skepticism and political resistance. Backed by the Rockefellers and the Port Authority, the project displaced 300 businesses and risked unprecedented engineering challenges, from deep slurry walls to cranes climbing 110 stories. Despite these hurdles, the towers stood as proof that ambition and innovation could reshape a skyline and an industry. Yet not all costs are fully documented. The long-term health of displaced communities and some details of internal debates remain unclear. Today, every super-tall building carries lessons from the Twin Towers, adopting their structural advances while enforcing stricter safety codes. The evidence shows the Twin Towers changed global engineering, but also marked the end of an era when risk and vision overruled caution. Their legacy is visible in every modern skyscraper that dares to reach higher,